Hello everyone, welcome to Vyas Edification. In this session we are going to discuss class 12th chapter number 4 moving charges and magnetism and exercise solutions. Clear? So here you will find detailed solution of each and every question, as well as you will find here concept behind that solution also. Clear? So definitely you will learn here a lot of concept by the questions. Clear? So now we are going to discuss each and every question, so concentrate on a screen. Now dear student, we are going to discuss question number 4.1, and in this question it is given to you a circular coil of wire consisting of 100 turns and having radius 8 cm carries a current of 0.40 ampere. Clear? So first let us try to understand what is the given situation. So in this question it is given to you, we have a circular coil. So let's suppose I am having here circular coil. Let's suppose like this, and each turn is having same radius. Let's suppose I am drawing like this. So let's suppose I have a circular coil of wire consisting of total 100 turns. So I am saying capital and we have this is 100. Clear everyone? Each of radius 8 cm. So I am saying R. This is, I can say 8 cm means this is 8 cm, or you can write like this, 8 into 10 to the power minus 2 meter. Clear? It carries a current of 0.40 ampere. It means I can say it is carrying current 0.40 ampere. Clear? Now what is the magnitude of magnetic field at the center of a coil? Clear? So my dear student, you know here you can actually find value of magnetic field at the center of a circular coil by using Biot-Savart law. Clear? So directly you know formula. Magnetic field at the center of a circular coil, this is given by mu naught Ni divided by 2R. Clear? Here mu naught is what? This is the permeability of a free space, or we can say vacuum. Clear? So value of mu naught we have 4 pi into 10 to the power minus 7 multiplied. Number of turns we have 100. If we talk about current, so current carrying this is 0.40 ampere. It is divided by 2 into, and radius of this circular loop. So radius of this circular loop is given 8 into 10 to the power minus 2. Clear everyone? So we can write like this. If you calculate, you can say 4 pi into 10 to the power minus 5 multiply 40 into 10 to the power minus 2 and divided by 16 into 10 to the power minus 2. I can say this one and this one cancelled out. Clear? So from here you can see this 4 and this 16, this is also cancelled. Clear? So from here I can write here value of magnetic field at the center of a coil. This is given by, or we can say this is pi multiply 10 to the power minus 4. Clear everyone? And this value is in Tesla. Clear? We have unit of magnetic field, this is Tesla. So from here we can say value of B, this is given by 3.14 into 10 to the power minus 4 Tesla. Clear everyone? So this is the solution of this question. Clear? So can we find here direction also? Because we know magnetic field is a vector quantity. Yes. So let's suppose I am saying here, let's suppose here this is a circular loop, and let's suppose current is actually flowing in an anti-clockwise direction. At that time you can actually curl your finger like this, then the thumb indicates the direction of magnetic field. So now we can say you will find here direction of magnetic field that is perpendicular outward of this screen. Clear? And you can say this is like this. Clear everyone? But in this question our objective is only to find magnitude of magnetic field, so that value is given by 3.14 into 10 to the power minus 4 Tesla. Clear? So this is all about this question. Now dear student, we are going to solve question number 4.2, and in this question it is given to you a long straight wire carries a current of 35 ampere. What is magnitude of magnetic field at a point 20 cm from the wire? Clear? So now we can say, let's suppose I am saying, let's suppose this is a straight wire. Clear? And let's suppose this is a long straight wire. Long straight wire means we can say this is going up to infinity. Clear? in this question it is given that a current of 35 ampere it is flowing. So let's suppose current that is flowing here I, this is equal to 35 ampere. Clear? Now our objective in this question is to calculate magnitude of magnetic field at B. Clear? So let's suppose we want to find magnetic field at this point B, that is at 20 centimeter from wire. So 20 centimeter from wire. Now dear student, do you know what is formula of magnetic field due to a long straight current carrying wire? Clear? It is given by B, this is equal to mu naught I upon 2 pi r. Clear? So from where this formula is derived, we can say actually from Biot-Savart law we know this is given by mu naught I over 4 pi r. I can say this is sine of theta 1 plus sine of theta 2. Now we can say from this point B, if we see, because this is a very long wire, so I can say this angle is 90 and this angle is also 90 degree. Clear? So we can say here we have angle 190 and 90, so I can put here theta 1 equal to 90 and theta 2 equal to 90. Clear? So I can say this is given by mu naught I upon 4 pi r and this is sine 90 plus sine 90. Clear everyone? So from here we can say this is equal to 1 plus 1 plus 1 equal to 2. So we can say this is given by mu naught I divided by 2 pi r. Clear? So like this we can derive this formula of magnetic field due to a long wire, and we are calculating this magnetic field at a distance r from this straight wire. Clear? So now concentrate, now come to the solution of this question. Okay, always keep in mind magnetic field is a vector quantity. It is always associated with direction. Clear? So now we can say first how can we find here direction? Actually direction of a magnetic field is determined by using right hand thumb rule. Clear? So we can say if we say thumb indicate the direction of a current, at that time we can say curling finger represent direction of magnetic field. So I can say magnetic field direction is given by this cross. Clear? Clear? What I am saying to you, direction of this magnetic field is represented by cross. It means perpendicular inward. Clear? So now I can calculate here value of magnetic field, value of mu naught. This is 4 pi into 10 to the power minus 7 into current that is flowing in this wire. We have 35 divided by, we can say 2 pi and multiplied value of r. Value of r is given 20 into 10 to the power minus 2. Clear? So from here we can say this value is 2. Clear? So we can say 70 into 10 to the power minus 7 divided by 20 into 10 to the power minus 2. Clear? From here we can say this one and this one cancelled out. From here you can say this is 3.5 into 10 to the power minus 5 Tesla. Clear to everyone? So from here we can say magnetic field at a point P, that is at a point any point you can say, let's suppose we are saying P. So magnetic field at point P at a distance 20 centimeter from this long straight wire, it is given by 3.5 into 10 to the power minus 5 Tesla. Clear? So this is all about this question. Now dear student, we are going to discuss question number 4.3, and in this question it is given to you, we have a long straight wire in the horizontal plane carries a current of 50 ampere. Clear? 50 ampere current in north to south direction. Now listen very carefully. Actually north direction is what I can say, this is a north direction, this one is south direction, this is east direction, and this one is west direction. Clear? But how can we represent this direction on a screen? So I am taking here, let's suppose I am saying I am drawing, let's suppose this is a north direction, this one is north, let's suppose this is south, this one is east, and this one is west. Clear? So in this question it is given to you, a long straight wire in a horizontal plane carries a current of 50 ampere in north to south direction. It means, let's suppose I am saying we have a wire like this. Clear? We have a wire like this. Let's suppose this is straight wire. and this is a very long wire from infinity, minus infinity to plus infinity. Clear? It is carrying a current of 50 ampere north to south direction. So I can say current is carrying like this, north to south direction, this is 50 ampere. Clear to everyone? Okay. Give the magnitude and direction of B at point 2.5 meter east of a wire. So we can say east is lie on the right side. So I am taking here, this is a point. Let's suppose this is a point P where we have to find magnetic field and at a distance 2.5 meter. Clear? Now we can say again we have a very long wire. So whenever we have a long wire, how can we calculate value of magnetic field? Magnetic field is calculated by one formula. This is mu naught I upon 4, this is 2 pi r. Mu naught I upon 2 pi r. Clear? So value of mu naught we know, this is given by 4 pi into 10 to the power minus 7 multiply. Now if we talk about value of a current we have, this is 50 ampere divided by, I can say 2 pi and distance that is given to you 2.5 meter. Clear? So we can say 4 pi into 10 to the power minus 7 into 50 divided by, I can say this is 5 pi. Clear? We can say pi and pi cancel, this one is 10. Clear? So from here you can say we are getting value of magnetic field B. This is given by 4 into 10 to the power minus 6 Tesla. Clear? So this is value of magnetic field. Clear? Now important part is here, how can we find direction of a magnetic field? Clear? So let's suppose I can say, because this is a long straight wire, let's suppose this thumb is indicating direction of electric current. Clear? I can say, now I can place my hand like this. I can say like this. This downward thumb, this indicates the direction of a current. Point is like this side. If I curl my finger like this, I can say magnetic field is lying, that is perpendicular outward. Clear everyone? So I can say direction of magnetic field is perpendicular outward of this screen. Clear? So we can say magnetic field value we have 4 into 10 to the power minus 6 Tesla. Clear? So this is all about this question. Now dear student, we are going to solve question number 4.4, and in this question it is given to you, a horizontal overhead power line carries a current of 90 ampere in east to west direction. Clear? So concentrate, let's suppose I am saying, I am assuming here, let's suppose this direction is north, this one is south, this one is east and this one is west. Clear? In this question it is given, a horizontal overhead power line carries a current of 90 ampere in east to west direction. It means the direction of current is this one and the value of current is given to you, this is 90 ampere. Clear? Now what is magnitude and direction of magnetic field due to current 1.5 meter below the line? So I can say, let's suppose I am saying, let's suppose I want to find magnetic field at this point P and distance is given to you 1.5 meter. Clear to everyone? So my question is here that first here calculate the direction, or first find here the direction of magnetic field. Now we can say thumb indicates the direction of magnetic field. So we can say, let's suppose thumb is indicating like this. This is not a straight one, you can assume. So let's suppose this is a current, direction of a current. We can say now finger is in the direction of a point. Now the curling finger represent direction of magnetic field. So I can say here direction of magnetic field we will find perpendicular outward of this screen. Clear? So I can say direction is perpendicular outward. Perpendicular outward. Clear? So now we can say this is perpendicular outward. So now can we calculate here value of magnetic field? Can we calculate here value of magnetic field? I can say value of B, this is given by mu naught I upon 2 pi r. Clear? So mu naught I upon 2 pi r, mu naught value we can say this is given by 4 pi into 10 to the power minus 7 multiply. If we talk about current we can say this is 90 divided by, we can say this is 2 pi and value of r, this is given to you 1.5 meter. Clear? So from here we can say this is calculated, that is 2. Clear? So we can say 2 into 10 to the power minus 7 into 90 divided by 15 multiply 10. Clear? We can say this value we have 6. Clear? So from here we can say 12 into 10 to the power minus 6 Tesla. So this is value of magnetic field. Value of magnetic field at point P. Clear? And the direction is perpendicular outward of this screen. Clear? So this is all about this question. Clear? Now student, we are going to solve question number 4.5, and in this question it is given to you what is the magnitude of magnetic force per unit length on a wire carrying a current of 8 ampere and making an angle of 30 degree with the direction of a uniform magnetic field of 0.15 Tesla. Clear? So concentrate on the screen. First of all, try to find what is objective of this question. Objective of this question is to calculate magnitude of magnetic force per unit length. Clear? So now we can say, because we have a current carrying wire, and whenever we have a current carrying wire and when we place that current carrying wire in a magnetic field, definitely it will feel a force. So we can say the value of that force, that is given by BIL, Bill sin theta. Clear? Where theta is what? Theta is the angle between magnetic field and the current. Clear? So we can write like this, because our objective in this question is to calculate force per unit length. So I can say this is equal to BI sin of theta. Clear? So value of B means magnetic field. Magnetic field we have 0.15 multiply. If we talk about current, current is given to you, this is 8 ampere, and we can say value of sin theta. Sin theta means we can say sin 30. Clear? So now we can say this is 0.15 multiply 8 into 1 by 2. Clear? So we can say this one is what, 4. So from here you can say this is 0.6, and we can say this is Newton per meter. Clear? So from here we can say force per unit length is given by, this is 0.6 Newton per meter. Clear? So this is all about this question. Now dear student, we are going to solve question number 4.6, and again this is a question based on a force acting on a current carrying wire. Clear? In this question it is given to you a 3 cm wire carrying a current of 10 ampere is placed inside a solenoid. Clear? So actually inside a solenoid, if we are talking about solenoid, so solenoid, if we are flowing current in a solenoid, it will have a uniform magnetic field along its axis. Clear? So now we are placing a current carrying wire having length 3 cm in a solenoid. It means definitely we can say current carrying wire is placed in a magnetic field, so definitely it will feel a force. Clear? So now our objective in this question, the magnetic field inside the solenoid, it is given. So what is magnetic force? So directly we can say formula based question this have. We can say force is given by BIL sin of theta. Clear? So value of magnetic field. Value of magnetic field we have 0.27, and the current is given to you, this is 10, and what is length of this wire? Length of wire is given 3 into 10 to the power minus 2, because it is placed perpendicular. Clear? It is placed perpendicular to axis, so I can say angle between current and the magnetic field is 90. Clear? So we can say this is 27 by 100 into 10 into 3 into 10 to the power minus 2. Clear? So now we can say this is 81. We can say this is divided by 10 into 10 to the power minus 2. Clear? So from here we can say 81 into 10 to the power minus 3, and this value we have Newton. Clear? So this is a value, or we can say this is a magnetic force acting on a wire. Clear? So this is all about this question. Now we are going to solve question number 4.7, and in this question, actually this question is related to current carrying wire, two current carrying wire when placed parallel to each other, definitely one force that is acting between the wire. Clear? If current is carrying in a same direction, force of attraction will act, and if the current is carrying in an opposite direction, we can say that attractive force, that is we can say repulsive force will act. Clear? So now we are going to solve first the derivation of that force, and after that we can put here values and we can get our answer. Clear? So first I am telling you the concept behind that question, after that we will solve this question. Clear? So concentrate. Let's suppose I am saying, let's suppose here we have a wire, let's suppose this is again a wire. Clear? Let's suppose this is very long wire, very long wire. Clear? Now let's suppose distance between these two wires we have, this is D. Let's suppose current that is flowing, this is I1, and let's suppose this is I2. Clear? So now first can I find value of magnetic field due to this current carrying wire 1? Yes or no? Let's suppose I am saying this is 1, this one is 2. So can I find value of magnetic field due to 1 on 2? Yes, because this is a long straight current carrying wire. I can say magnetic field is given by, magnetic field on 2, this is given by mu naught I upon 2 pi r. I we can write this is mu naught I1 upon 2 pi r. I can say this is 2 pi d. Clear? Now you can say actually we are placing this current carrying wire in a magnetic field of number 1 wire. Yes or no? It means definitely it will feel a force. Yes. So when it will feel a force, we can say, listen carefully, what is direction of magnetic field? Definitely I can say direction of a magnetic field is given by perpendicular inward. So perpendicular inward is the magnetic field and the direction of current is this one. So we can say angle between them is 90 degree. So I can say, we can write like this, F equal to what? This is Bill sin theta, Bill. So I can say this is B2 I, current that is flowing I2, and we can say L. So we can say, let's suppose L is L. Clear? So from here we can say, we can write like this, value of B2 we have mu naught I1 I2 divided by 2 pi d, and this is multiplied with L. Clear? Now can we calculate here the direction of magnetic field also? Yes, definitely. So from here you can say, you can utilize this Fleming left hand rule also. So from here you can say, let's suppose this finger represent the direction of, first finger represent direction of magnetic field, and we can say, let's suppose middle finger represent direction of current. You can say thumb represent direction of force acting. Clear? It means I can say here force will acted in this direction, force acted on 2 by 1. Clear? Similarly you can find magnitude of a force acting on 1 due to 2, and I can say it is having same magnitude, but if we talk about direction, direction is opposite. So we can say here an attractive force is acting between these two wires. Clear? So this is the magnitude, that is the force acting between these two wires. Our objective here in this question is to calculate force on a 10 centimeter section of a wire A. Clear? So now just I am writing here values and I can get here answer. So now if I write here F, this is equal to mu naught. Mu naught value is given 4 pi into 10 to the power minus 7 multiply I1 I2. I1 I2 is given, that is, just a minute, again I am writing here. Listen carefully. So I can say value of force, this is given by mu naught I1 I2 divided by, I can say 2 pi, we can say d, and multiplied with L. Clear? So value of mu naught we can say 4 pi into 10 to the power minus 7. Clear? Okay. Value of current I1 and I2, this is given 8 and 5. I can say 8 multiply 5 divided by 2 pi. Clear? And multiplied with d. Clear? So d is given to you 10 centimeter, that is 4 centimeter. Clear? They are separated by a distance 4 centimeter. 4 into 10 to the power minus 2. Clear? And we have to find force acting on a segment 10 centimeter. So 10 into 10 to the power minus 2. Clear? From here we can say this one and this one cancelled out. Clear? 4 pi cancelled out. Clear? From here we can say this is 4. Clear? So from here you can say this is 20 and we can say 200. So 200 into 10 to the power minus 7, this is Newton. Clear? So what is our correct answer? Correct answer we can say 2 into 10 to the power minus 5 Newton. So we can say this is a force acting or we can say attractive force acting between these two wires. Clear? So this is the magnitude. Clear everyone? So like this you can calculate the answer of this question. Clear? Now dear student, we are going to discuss question number 4.8, and in this question it is given to you a closely wound solenoid 80 cm long has 5 layers of winding 400 turns each. Okay. The diameter of the solenoid is 1.8 cm. If the current carried is 8 ampere, then estimate the magnitude of B inside solenoid. Clear? So let's suppose, my dear student, I am taking here one solenoid. Let's suppose you can assume this is a solenoid. Clear? In this question it is given to you, it is having length 80 cm. So let's suppose I am indicating length by L. L value is given 80 cm. Okay, fine. It is having total 5 layers of winding. So we can say each having 400 turns. Clear? So can we calculate number of turns? Yes. How can we calculate? We can write like this: number of layers multiply number of turns per layer. Number of turns per layer. Clear? So in this question it is given to you number of layers we have 5 and it is multiplied by 400 turns. So I can say this is equal to 2000. Clear? So we can say number of turns, this is given to you 2000. Clear to everyone? Okay. The diameter of a solenoid, this is given 1.8 cm. So diameter of solenoid is 1.8 cm. I can say this is 0.9. I can say the radius is given by 0.9 cm. Okay, fine. Now current carried, it is given to you, that is 8 ampere. So I can say I is given to you 8 ampere. Clear? How can we find magnitude of magnetic field at the center of this solenoid? So actually we know our standard formula, that is magnetic field produced inside a solenoid near its center. This is given by B equal to mu naught small n into I. Clear? Now we know very well value of mu naught, we have 4 pi into 10 to the power minus 7 multiply small n. Small n is what? Generally students commit a mistake here. Small n is not a number of turns. Small n is a number of turns per unit length. Clear? So number of turns we have, that is we can say 2000, and this is per unit length. So I have to divide with 80 into 10 to the power minus 2. Clear? And the current carrying, this is given to you 8 ampere. Clear? So I can multiply it with 8. So now you can say, sir, there is no use of any diameter. Yes, we do not have any use of diameter here. Clear? So we can say 4 pi, I can say this is 10 to the power minus 5. So 4 pi 10 to the power minus 5, and we can say this one cancelled out, 8 is also cancelled out. So 2 into 10 to the power 2. Clear? So from here we can say this is given by 8 pi into 10 to the power minus 3, and we can say this value we have Tesla. Clear? So we can say magnitude of value of magnetic field. Value of magnetic field, it is given by this is 8 pi into 10 to the power minus 3 Tesla. Clear? So this is all about this question. Now dear student, we are going to discuss question number 4.9, and in this question it is given we have a square coil of side 10 cm. Clear? So I am saying here side means I can say, let's suppose side A, it is given 10 cm. Okay, it consists of 20 turns, means number of turns is given to you, this is 20. It carries a current of 12 ampere. The coil is suspended vertically and normal to the plane of the coil makes an angle 30 degree with the direction of uniform horizontal magnetic field. So BH, this is given to you 0.80 Tesla. Clear? So horizontal magnetic field, this is given to you 0.80 Tesla. Clear? So what is magnitude of torque experienced by coil? Clear? So now we know very well. Let's suppose we have a square coil, we are suspending vertically, and let's suppose the plane of that coil is making some angle with magnetic field. Clear? So we can say the angle between them is given to you 30 degree. So torque experience. So we know formula of torque. This is given by Bina sin theta. That is BINA sin theta. Clear? So from here we can say value of magnetic field. Value of magnetic field we have 0.80 multiplied with, I can say current. Current is flowing, that is 12. Number of turns. Number of turns if we talk about, I can say we have 20. And if I talk about cross section area, we can say side is given 10. So 10 multiplied 10. This is centimeter square. We can convert into meter square and multiplied with sin theta. So we can say this value we have sin of 30. Clear everyone? So from here we can say, we can write like this. This is 4 by 5 multiply 12 into 20 or 200. Clear? And we can say this is 10 to the power minus 3 and this is 1 by 2. Clear? We can say this becomes 100. Clear? So this is equal to, we can say 4 by 5 into 12 into 10 to the power minus 1. Clear? So from here we can say, if we write, we can write like this. This is 48 divided by 10 divided by 5. Clear? So we can calculate torque like this. 4.8 divided by 5. This is 0. We can say 9. Clear? We have 3 left, so we can say 0.96. Clear? So from here we can say torque acting on that square loop, this is given by 0.96 Newton meter. Clear to everyone? So this is all about this question. Now dear student, we are going to discuss question number 4.10, and in this question it is given to you two moving coil meters M1 and M2 have the following particulars, and value of M1 and M2 is given to you, that R1, A1, R2, A2 all are given to you, B1, B2 is also given to you. Clear? Spring constant are identical for 2 meters. This is given in a question. Then now we have to determine the ratio of current sensitivity and voltage sensitivity of M2 and M1. Clear? So my dear student, definitely whenever we studied about construction of a galvanometer, there we find one principle, and according to that principle we can say, actually we know Bina, B-I-N-A, this should be equal to K times of alpha. Clear? Where K is a spring constant. So first if I talk about current sensitivity. So current sensitivity is defined as deflection per unit current. Clear? So from this formula we can write deflection per current. This is given by NBA divided by K. Clear? So if I find here ratio for M2 over M1. Clear? So I can say current sensitivity. Let's suppose if I find for M2 over M1. Clear? How can I write? Because value of spring constant is same, so I can write like this. This is N2 B2 A2 divide by, this is N1 B1 and this is A1. Clear? So N2 is given to you. Yes, 42. So I can say 42 by 30. Clear? B2 by B1. B2 value given 0.5 and this is 0.25. 0.25 multiply A2 by A1. A2 value is given 1.8 into 10 to the power minus 3 and divided by, I can say 3.6 into 10 to the power minus 3. We can say this one and this one cancelled out. Clear? So from here we can say 42 by 30 multiply 2. Directly we can say this is 2 times and we can say this is 1 by 2 times. Clear? This one and this one are also cancelled out. So now we can find value of current sensitivity. This is 42 by 30. Clear? So now we can say if we cut by 10, we can say this is 10 by 1 and this is 4. So we can say this is 7 by 5, or this is the ratio of current sensitivity for galvanometer M2 and M1. Clear to everyone? Now if I find voltage sensitivity, listen carefully. If I talk about voltage sensitivity, so voltage sensitivity means, first if we talk about expression, this is Bina, this is equal to K alpha. Clear? Now we know voltage sensitivity. So voltage sensitivity is defined as voltage sensitivity. It is defined as, we can say alpha divided by V. Clear? So deflection per unit voltage. This is defined as voltage sensitivity. Now we know actually alpha by V we can also write like this. This is I multiply R. Clear? So alpha upon I we have current sensitivity. Clear? So actually we can say this is defined as current sensitivity divided by we can say resistance. Clear? So now you can say current sensitivity we already find, this is NBA divided by K, and it is also multiplied with alpha. So I can write M2 by M1, this is N2 B2 A2 divided by K2. Clear? And we can say this is R2. Clear? This value we have R2. Now we can write same for galvanometer M1. So this is written like this, N1 I can say B1, this is A1, and this is divided by R1. Clear everyone? So from here we can say, we can write like this, N2 by N1 dot we can say B2 by B1. Clear? And this is A2 by A1, and this is R1 by R2. Clear everyone? So from here we can say, now if we put all the values we can directly get our answer. Clear? So now we can say M2 by M1, N2 by N1 already we know 42 by 30. Clear? B2 by B1, B2 by B1 means 0.50 divided by 0.25. Clear? Multiply A2 by A1, A2 is given to you, yes, 1.8 into 10 to the power minus 3 divided by 3.6 into 10 to the power minus 3 and multiplied by R1 by R2. R1 is 10, R2 is 14. So this is 10 by 40. Clear? So you know that we have already solved this parameter. Clear? And we find this is equal to 14 by 10. Yes or no? And resistance is given to you in the ratio of 10 by 14. It means here we will get ratio of voltage sensitivity. This is 1:1. Clear everyone? So like this you can solve this question. Clear? So this is all about this question. Now dear student, we are going to discuss question number 4.11, and in this question it is given to you, in a chamber a uniform magnetic field of 6.5 Gauss is maintained. Clear? So let's suppose I am taking here, let's suppose I am taking this chamber. Let's suppose I am denoting chamber like this. Clear? So let's suppose this is a chamber and a uniform magnetic field is maintained. So let's suppose I am assuming magnetic field is perpendicular inward of this screen. I am just assuming. Clear? And value of magnetic field is given to you B. This is equal to 6.5 Gauss, or we can say if we convert Gauss into Tesla, then we can say it should be multiplied with 10 to the power minus 4. Clear? And now we can say this value we have in Tesla. Clear? Now it is maintained, an electron is shot into the field with a speed of this one. Clear? So let's suppose I am assuming electron is entering from this side. Just a minute. Yes. So let's suppose I am assuming this is just a pass. Clear? Here we have uniform magnetic field. Clear? Now let's suppose electron is entering from this side. Clear? So this is a side for the electron. Clear? So now let's suppose I am assuming electron is actually entering from this side. Clear everyone? Now we have to find that an electron is shot into the field with the speed of this one. It means value of speed is also given 4.8 into 10 to the power 6 meter per second. This is given to you. Clear? It is normal to the magnetic field. So definitely we are assuming this is an electron and this electron is going perpendicular to magnetic field. Fine. Explain why the path of an electron is a circle. Clear? Now listen carefully. We can say magnetic field is perpendicular to this screen and electron is going in this direction, that is in this plane. Clear? It means now we can say, if we talk about, let's suppose we have any charge and that charge is moving in a magnetic field. Clear? So whenever a charge moves in a magnetic field and magnetic field is perpendicular to that motion of a charge, at that time we can say a centrifugal force will act. Clear? Or you can say we can also find direction of that force by using right hand thumb rule. Clear? So how can we find? You can say, let's suppose this is a right hand. So you can see, let's suppose these fingers are representing direction of a magnetic field. Clear? This thumb is indicating direction of a motion. Definitely I can say this palm represent direction of a force. Clear? So now we can see when this electron is going like this one, definitely we can say a force will act in an upward direction. So it will try to deflect this electron in this direction. Clear? As soon as it reaches to this point, again we can say a centrifugal force will act, centripetal force will act in this direction. Again we can say here we will find deflection of an electron. Clear? So like this, let's suppose this chamber is enough large. At that time we can say this electron move in a circle. Clear everyone? So first question of this particular question is here, explain why the path of an electron is a circle. Clear? Because we can say force acting on that charged particle is perpendicular to magnetic field as well as perpendicular to direction of motion or perpendicular to velocity of a electron. So we can say here directly we can see actually a centripetal force will act, and this centripetal, due to this centripetal force we can say this charged particle move in a circle. Clear everyone? So now we can say this is a region, and now we have to determine what is radius of this circular path. So we can say force acting, this is given by QVB. Clear? And we can say this is sine. Now here we will write angle theta, and theta is the angle between velocity vector and magnetic field. So we can say velocity vector and magnetic field both are perpendicular to each other. So I can say this is sine 90. This is equal to, now whatever the force this is acting here, this force is providing necessary centripetal force. Clear? So I can say this is equal to mv square by r. So I can say this is mv square divided by, I can say radius is r. Clear? So from here we can say, we can write like this, QVB, this should be equal to mv square by r. Clear? So we can say v and v, this one is cancelled out. Clear? So now from here we can write like this, r is equal to mv divided by qb. Clear everyone? R is equal to mv divided by qb. Clear? Now if we talk about mass, so definitely we know mass of an electron, this is given by 9.1 into 10 to the power 31. So 9.1 into 10 to the power minus 31 multiplied with, now velocity vector, velocity is given to you 4.8 into 10 to the power 6. 4.8 into 10 to the power 6 divided by charge of an electron 1.6 into 10 to the power minus 19. Clear? And value of magnetic field, value of magnetic field is given 6.5 Gauss. So we can say 6.5 into 10 to the power minus 4. Clear? Now we have to solve this expression and we can easily calculate value of radius of this circular path. Clear? So now concentrate. Yes. Now from here we can see value of r, this is given by 9.1 multiply 4.8. So 9.1 multiply 4.8, and it is also multiplied with 10 to the power minus 31 and 10 to the power 6. So 10 to the power minus 25 and divided by, clear, 1.6 into 6.5. 1.6 into 6.5 and multiplied with, I can say this is 10 to the power minus 23. Clear? So from here you can say this one is 3 times. Clear? So 3 into 9.1 divided by 6.5, and we can say this is 10 to the power minus 2. Clear? And this is in meter. Clear? Now let's suppose I am assuming this is approximately 6.6. Clear? So 6.6 means we can say this is 2.2. Clear? Now here you can say 9.1 divided by 2.2, or we can say 91 divided by 22. It means this is approximately equal to, we can say 4.2 into 10 to the power minus 2 meter. Clear? So this is the radius of this circular path. Clear everyone? And we can also say the radius is given by 4.2 centimeter. Clear to everyone? Clear? So this is all about this question. Now dear student, we are going to discuss next question, question number 4.12, and in this question it is given to you, in a chamber a uniform magnetic field of 6.5 Gauss is maintained, clear, and an electron is shot into the field with a speed of this one, this is given to you, clear. Obtain the frequency of a revolution of an electron in a circular orbit, clear. So now concentrate on a screen. So actually this is just given situation, we have a chamber and inside the chamber we have uniform magnetic field, clear. So I am assuming, let's suppose I have, this is a chamber, clear, and in this chamber we have uniform magnetic field like this. This is a magnetic field perpendicular inward, clear. Now let's suppose an electron is entered from any side, let's suppose electron enter at the center, clear, or at any position. Let's suppose electron is entering from here, and let's suppose at the time velocity vector of an electron in this direction. So definitely we know whenever we have velocity vector perpendicular to magnetic field, clear, at that time we can say a force will act along the radius and we can say towards the center, clear, and we can say that force, or we can say magnetic force, it behaves just like a centripetal force, clear. So necessary centripetal force is provided by magnetic force. So due to that force we can say this electron move in a circular path like this, clear everyone. And we can say, let's suppose here we have a center, so definitely we can say at any instant force will act in this direction, clear. So now in this question our objective is to calculate frequency of revolution of an electron, clear. So my dear student, actually we know time period t, so we can say time period capital T, this is given by, I can say 2 pi r by v, clear, and we know expression of a radius, this is given by 2 pi by v, I can say r, this is mv by qb, clear. From here we can say v and v is cancelled out. So time period of this revolution or time period of this electron, this is given by 2 pi m divided by qb, clear. Now if I talk about frequency, frequency is equal to 1 by capital T, clear, and this is given by qb divided by 2 pi m, clear. So now this is the expression of frequency, clear. Now actually we can say here velocity term is cancelled out, clear. It means I can say, does the answer depends on speed of an electron? No, because term of a speed is cancelled out, clear. So now we can say frequency, we can write like this, qb divided by 2 pi m, clear. Now value of q means we can say charge is given by that is charge of an electron, so 1.6 into 10 to the power minus 19 multiply. Now if I talk about b means we can say this is 6.5 into 10 to the power minus 4 and it is divided by, I can say this is 2 pi and multiply m. Mass is given, we know actually that is 9.1 into 10 to the power minus 31, clear everyone. Now we can solve it easily, directly we can say 16, this is 10 to the power minus 19, this is 65, and or we can write like this, listen carefully, we can say this is 1.6 into 6.5 into 10 to the power minus 23 divided by, clear, I can say this is 2 pi into 9.1 into, I can say 10 to the power minus 31, clear everyone. Now we can solve it. So frequency of this electron or frequency of this revolution, that is given by f equal to 1.6 into 6.5 into 10 to the power, I can say this is 10 to the power 8, clear, and divided by 2 pi into 9.1, clear. Now we can say here we have 1.6, clear. So you can say, let's suppose this is 0.8, clear everyone, 0.8, clear. So we can say f is given by 0.8 into 6.5 into 10 to the power 8 divided by, I can say this is pi multiply 9.1, clear. Now we have to take here approximation, clear. So how can we take here approximation? Let's suppose we can say this decimal and this decimal is cancelled out, clear. So now I can say this value we have, we can say 3.1, clear, and this is 9.1, So if we multiply both, that is 27 point something, clear. So 27 point something, it means we can say f, this should be equal to, I am just writing like this, 8 by 10 into 65 divided by pi. I can say this is 22 by 7, I am writing like this, clear. 8 by 10, 65 divided by pi, clear, and we can say this is 10 to the power 8 and divided by 91, clear. So now we can say, we can write like this is 1 and this is 3, we can say this one is 5, clear. I can say this one is 2, this one is 4, clear everyone. So now here you can say calculation is now becomes very easy. I can say value of f, I can write like this, this is 4 divided by 22 and multiplied with 10 to the power 8, 10 to the power 8, clear. So now I can say, we can write like this is 2 by 11 into 100 into, I can say this is 10 to the power 6 and this value comes in a hertz, clear. So this is 200 divided by 11 and 10 to the power 6 and this is hertz, clear. So now I can say value of this frequency, this one is given by, I can say this is 1, we have 9 left, we can say this is 18, clear, we have 2 left, so this is 1. So 18.1 into 10 to the power 6 hertz, clear. So we can see frequency value is approximately, we can say 18.1 megahertz, clear. So this is the answer of this question, clear to everyone. So this is all about this question. Now student, we are going to solve question number 4.13, and in this question actually we have two parts, part number A and part number B, clear. So in part number A, question is given to you, a circular coil of 30 tons and radius radius 8 centimeter carrying a current of 6 ampere is suspended vertically in a uniform magnetic field of magnitude 1 Tesla. Okay, the field line makes an angle 60 degree with normal to the coil, clear. It means we can say angle between magnetic field and the area vector, this is 60 degree, clear. So now concentrate. First of all I am writing here all the parameters that is given to you. So in this question we can say we have number of tons, this one is 30, clear. We have number of tons 30, clear. Radius is given to you, r equal to 8 centimeter, clear. It is carrying a current of 6 ampere. So I can say current is given to you 6 ampere. It is suspended vertically in a uniform horizontal magnetic field having value of B, this is 1 Tesla. Okay, fine. Field lines make an angle 60 degree with the normal. It means I can say angle between theta, or we can say angle between area vector and we can say magnetic field, this is given by 60 degree, clear. Now in this question it is given to you, calculate the magnitude of counter torque that must be applied to prevent the coil from turning. It means definitely we can say whenever there is an angle between area vector and the magnetic field, we find a torque will act on that we can say circular coil, clear. So when the torque will act, definitely we can say torque is given by one formula, this is beta sine of theta, clear. Torque is given by beta sine theta, clear. Now we can say actually this torque is acting on this circular coil and this torque will try to rotate that coil, but we have to find the value of counter torque so that we can place that coil in a stable position. It means I can say counter torque is also having same in magnitude but direction is opposite, clear. So I can say value is given by beta sine theta. Beta means B means we can say 1, I we can say this is 6, number of turns we have 30, area vector. Now important part, area vector, because this is a circular coil, I can say area is given by pi r square. So pi, value of r is given 8 into 10 to the power minus 2 whole square and multiply, I can say this value of sine, so I can say this is sine 60, clear everyone. So this is equal to 6 into 30 into pi into 8 into 8 into 10 to the power minus 4 into we can say this is under root 3 by 2, clear. So I can say this is value, that is 4, Clear? First we simplify all the thing. 6 into, I can say this is 30 into pi into 8 into 4 into under root 3 into 10 to the power minus 4. Clear everyone? Now listen carefully. Now we have to just solve and we will get our answer, value of torque. Clear? So now we can say value of torque, this is given by, I can say this is 180 multiply, I can say 22 by 7. Clear? Here we have 32. Clear? And we have here root 3. So I can say 1.73 or into 10 to the power minus 4. Clear? So how can we calculate? We can say here we have almost 5, or we can write almost, we can say this is value approximate, I am taking 3. Clear? Value of pi I am taking approximately 3. Clear? So I can say this is 540 into 32 into 1.73, or you can write like this 173 into 10 to the power minus 6. Clear? So now first you can multiply 540 with 32. Clear? Or you can multiply with 173 with 540. So we can write like this, first I am multiplying 540 with 32. So you can multiply just 54 with 32. How can we multiply? We can say this is 8, we can say this is 10 and 12, that is 22, and we can say this is 15. So 8271. Clear? So I can say 1728. Clear? So this value we have 17280 and multiply 173 into 10 to the power minus 6. Clear? Value you will get in Newton meter because this is a torque. Clear everyone? Yes. So now just multiply. Approximately you can say, okay, just multiply, better it will be 17280 and this is 173. So I can say I am just multiplying with this one. Clear? You can say we have here 4, we have 2, we can say 8, this is 1, we have 2 left, this one 5. Clear? We have 6, we have 5, 14, we have 19, again we have 1, this is 50, we have 5, so we can say 12. Clear? And if we multiply it with 1, we can say 8, 2, 7, 1. Clear everyone? So from here we can write this is 4, we can say 8, 4, this is 8 or 6, we can say this is 14, we have 1, so 2, 9, 11 and we can say 20, we have 2, 7, 2, 9, we can say this is 9 and this is 2. Clear? So from here you can say we are getting value 299044. Clear? And this is multiplied with 10 to the power minus 6 Newton meter. Clear? So now you can say 1, 2, 3, 4, 5, 6. Clear? It means we will get here value of counter torque, this is 0.299044 Newton meter. Clear? So if you simplify it, you can say, because we are taking here approximate, so we can say correct answer will be approximately 0.3 Newton meter. Clear everyone? So like this you can solve. Definitely calculation is lengthy because this is related to NCERT. So you can actually solve this question very easily if you do some calculation like this. Clear everyone? You can take some approximation also. So approximately you will get here value of torque, this is 0.3 Newton meter. Clear everyone? So this is all about this question. Now student, we are going to discuss question number 4.14, and in this question it is given to you two concentric circular coils X and Y of radius 16 cm and 10 cm respectively lie in same vertical plane containing the north to south direction. Clear? So let's suppose I am assuming, concentrate on screen. Let's suppose I am assuming this direction is north to south direction. Clear? So first I am drawing here concentric coils. So let's suppose this is coil number 1 and let's suppose this is another coil. Clear? I can say this is having, here we have two coils, this one is in north direction, this one is south direction. Clear? So this is north south direction, this is given to you. Two concentric circular coil X and Y having radius 16 and 10 cm. It means outer one is X and this one is Y. Let's suppose this is center. So we can say here we have two radius like this, and value of radius is also given. So I can say I am writing this side. So value of Rx, this is given by 16 cm. Clear? and value of Ry, this one is given to you 10 centimeter. Clear? Now listen carefully. It is given in this question that coil X has number of turns 20. Clear? So I can say number of turns of coil X, this is 20, and number of turns in coil number Y, this one is given to you 25 turns. Clear everyone? And it carries, important part, it is also given current, coil X carries a current of 16 ampere. It means value of Ix, this is given 16 ampere. Clear? And coil Y carries a current of 18 ampere. Clear everyone? Yes. Yes, correct. Clear? So I can say Iy is given to you 18 ampere. Clear to everyone? Yes. The sense of a current X is in anti-clockwise direction and clockwise direction for Y for an observer looking at coil facing west. Clear? So let's suppose we can say this direction is east, here we have west, and let's suppose an observer is situated here and actually he is observing from this direction. Clear? It is given in a question that sense of current in coil X is anti-clockwise. So I can say anti-clockwise means I can say like this. Yes or no? Clear to everyone? You can say like this. This is anti-clockwise. Let's suppose I am an observer. I am observing from this side. So we can say, let's suppose this is a coil, and we can say direction of this coil is we can say towards east. Clear? Direction of magnetic field, this is towards east. Clear? So one more thing is given to you. We have a clockwise direction for Y. It means we have direction for Y like this. Clear everyone? Now we have to find magnitude and direction of net magnetic field due to coil at the center. Clear? So first I can calculate here value of Bx. Clear? So how can I write? Actually you can say here we have a closed loop and we have to find magnetic field at the center of a coil. Clear? So how can we calculate? We can write like this. This is given by mu naught n I by 2 r. Clear everyone? So now we can put here all values. Value of mu naught we have 4 pi into 10 to the power minus 7 multiplied with number of turns in coil number X. This is given to you. Yes, that is 20. Yes, multiplied with Ix. Ix is given to you 16 ampere and it is divided by 2 multiply value of Rx. Value of Rx is given 16 centimeter. So 16 into 10 to the power minus 2. Clear? So I can say this one and this one cancelled out. We can say this value we have 10. So 4 pi into 10 to the power minus 6 divided by 10 to the power minus 2. So 4 pi into 10 to the power minus 4. Clear? 4 pi into 10 to the power minus 4. Clear? And we can say this value is equal to, that is Tesla. Clear? So 4 pi into 10 to the power minus 4 Tesla, we have value for Bx. Clear everyone? So now we can also find here value of By. How can we write? I am just writing here values. Okay. We can say value of By. Value of By, this is given by. Okay, can we find here direction also? Yes or no? So for the Bx, I can say if I am observing from this side and I am having anti-clockwise direction, means like this, I can say direction of magnetic field is towards east. Clear everyone? So now we can say value of By. I can write like this, mu naught Ny Iy divided by 2Ry. Clear? So we can say value of mu naught. Value of mu naught is 4 pi into 10 to the power minus 7 multiply. We can say Ny. Ny we can say this is equal to 25. Ny equal to 25. Clear? And we can say Iy. Clear? So Iy we can say this is equal to 18. Clear everyone? It is divided by. Clear everyone? Ny is 25. Iy this one is 18 and 2 times of, we can say here. It is given to you 10 centimeter. So I can say 10 into 10 to the power minus 2. Clear? So now listen carefully. Yes, actually we can write here value of Bx. Clear? Value of Bx is given to you 4 pi into, clear? Value of Bx we have that is 4 pi into 10 to the power minus 4 Tesla. Clear? Now listen carefully. If we solve it, we can find here value of By. Value of By, this is given by, we can say 4 pi into 25 into 18 into 10 to the power minus 7. Clear? 10 to the power minus 7, and we can say this is 2 multiply 10 to the power minus 1. Clear? So from here you can say this is 2 pi. Clear? And we can say if you write it, we can say 2 pi into 25 multiply 18. So we can say here we have 200, we have 20, so this is 450. Clear? And this is 10 to the power minus 6. Clear everyone? So now if you write it, we can say 450 multiply 2, this is 900. Clear? So we can write like this, this is equal to 9 pi into 10 to the power minus 4 Tesla. Clear? So this is value of By. So can we calculate, can we find here direction of this By? Yes, because from this side, if we see from this side, we can see here we have a clockwise sense. Clockwise sense means if we curl our finger like this. Clear? Then we can say thumb indicate direction of magnetic field. So here we can say direction of magnetic field in the west direction. Clear? Here we can say here we have east direction. So can we find here value of net magnetic field? Yes. So how can I calculate? So I can calculate like this, value of B net, this one is given by By minus I can say Bx. Clear? So value of By we have 9 pi into 10 to the power minus 4 minus I can say this is 4 pi into 10 to the power minus 4. Clear? So I can say this one is equal to 5 pi into 10 to the power minus 4, and this value we have Tesla. Clear? So I can say value of B net, this one is given by 5 pi into 10 to the power minus 4 Tesla. Clear to everyone? And direction, what is the direction? I can say here we can say this direction is west direction. Clear to everyone? So like this we can calculate here net magnetic field in this question. Clear? So this is all about this question.